All right. So you wanted to look at 56, you say?
55.
55. Okay. Yeah, so these ones with the rational expressions are just kind of a pain in the buttocks. But that's okay. So 55, we have to do f of g of x. So that's f of negative x minus 5 over x minus 1. So I'm going to put in negative x minus 5 over x minus 1. And then minus 5 over negative x minus 5 over x minus 1 plus 1. We good with the composition there? Grace, right? Is who I was talking to?
Yeah, why do you put the minus 5 plus 1?
Okay, so what I'm doing is I'm taking my function g of x and plugging it into the x's for f of x. So the minus 5 is the rest of the numerator for f, and the plus 1 is the rest of the denominator for f. Is that okay?
Yeah.
And then to finish this off, what I need to do is simplify this down to get to x. So the trick here that I think makes life much easier is I'm going to multiply the top and bottom by x minus 1. I'm doing that because that's the denominator in my fraction inside of the bigger fraction. So I just distribute that through. When it multiplies to the fraction, the x minus 1's just cancel. I'll put a 1 there. Is that okay, Grace?
Yeah.
Then we'll just distribute. And then if we combine our like terms, the plus 5 and the minus 5 cancel. The minus x and the plus x cancel. I have negative 6x over negative 6. Just reduces down to x. And the other direction works similarly, right? Do I have to do both?
No, you're good. That's fine.
One direction is good, I hope.
Yeah.
Okay. No problem. Okay. Any others questions on things? Yeah, Raylan.
If a function is not one-to-one, then it can't be inverse.
The inverse will not be a function.
Right,
Correct.
So that happens every time, right?
Yes.
And then
Now you can make the function one-to-one if you restrict the domain. And that'll make the inverse then a function.
okay.
Which is like what we did when we did like, we had like x squared plus something, and we said, okay, let's just take the positive parts of this parabola, like 1/2 of the parabola, and then we can make an inverse function from that. But yes, if it is not one-to-one, then its inverse cannot be a function.
And then if it's not a function, it can't be one-to-one, or can it still be?
Sure, it could be one-to-one.
Okay, so it doesn't really, that part doesn't matter.
No.
Okay.
Right, so like if we just draw, so like, well, let's just pick something silly. So like a straight vertical line. Definitely not a function, right? But the y coordinates are used only once, right? The only time, say, this y coordinate gets used is by this specific value. So it is 1-to-1, but like not a function. Does that feel okay?
Yeah, and you could just, that's just like the horizontal line.
Right. Yep. So graphically, the easy way to check for 1-to-1 is with a horizontal line test. Yes. Mhm. Yeah, you're welcome. Anybody else? Okay. Let's talk a little bit about the test format, and then I'll get out of your way and let you guys work on whatever is your highest priority thing to be working on. Sound good? Okay. So we'll have 2 questions, and we'll ask for the domain. So I expect that you're able to do that algebraically so that you can show work to do that. And then we'll have 2 questions of odd, even, bless you, neither, again, should be able to give me some work as to how you got that. Two questions about determining whether something represents a function or not. Four questions or ask you to just kind of perform, I'll give you some functions and ask you to perform the operation, so whether they're addition, subtraction, multiplication, division, or composition. So you'll have 2 questions where I ask you to write the inverse in the same form as the function. So if I give you a graph, the inverse that I'd want back should be a graph. If I give you an equation, the inverse you give me back should be an equation. If I give you a mapping diagram, the inverse you give me back should be a mapping diagram, etc. Is that okay? Again, we did that. So you should be able to verify 2 functions are inverses. And again, you should do that using
They said B6.
that definition of an inverse. So if I give you some parent function and I would ask you to be able to describe the transformation to get some resulting function. So that's like, okay, it's, we did a reflection across the x-axis, we stretched it vertically and shifted to the right 4 places or whatever. Everybody's good with what I mean by that? you'll have a question where I give you a parent function, and I would ask you to find the resultant function after some transformations. And then the last question, I'm going to give you a parent function as a graph. And then ask you to draw the resultant function. And to describe its transformation in the correct order. Yeah, John?
So for that one, the last one there, we'll be given like 2 or 3 points from the parent function, and then we can do the transformations to those points to find that.
Yeah. Yep, that's the way that you'd want to do that. Jackson.
So is there not going to be a question on finding the range?
Correct. Everybody feel clear as to what I'd be asking from them for this? Again, the idea hopefully is that there's no surprises, that we've narrowed this down from talking about a lot of stuff to like, these are the things that I really want us to know.